this is the second part of our topic under simple harmonic motion, and it will be based on acceleration and velocities of simple harmonic motion. Now, let's start from where we stopped last week. Don't forget that when you have a simple harmonic motion with a simple pendulum bob like this, if you display it like this, like I told you, it will come to this place. And this point is called point of maximum displacement, which is referred to as what? Amplitude. Then it will now come like this to this place. So in that case, it will form what? A semicircle for the toe. Then to come back, we complete the circle, making toe and fro. Therefore, we are going to use circle to explain the formula. So if you have it like this, it will look like this half circle, where this place is what? Equilibrium position. So you have it like this. So if this object moves from here along this direction, and the body is moving like this, and the bulb is moving like this, the displacement is increasing. Therefore, let's assume the body is at this point. Now, you now dot it this place like this. Then this. Then this one will now serve as our what? R. Then the distance from here to here is what? The displacement x. Now, this place is the angle theta. And don't forget, when this body gets to this place, it means this length from here to here will become from here to here, which is same thing as the whole radius. That is, x at this point will become a. And our v from here is 0, because this is maximum displacement. Don't forget in our last video, that is the part 1 of this topic. Then when the body is coming like this one will be reducing until it will get to this place where this x will become 0. So at this point, x is equal to 0. Then our v is what? Maximum. Now, let's look for this one, this x. Let's find this x. While this one is hypotenuse, this is adjacent. Therefore, we are going to have cos theta is equal to adjacent over hypotenuse. And this hypotenuse is what? The whole length, that is r, which is same thing as amplitude a. Therefore, over a. Then when you cross multiply, we are going to have x is equal to a cos theta. And don't forget, our theta from circular motion, theta is equal to omega t. Then we can replace this one with omega t. So we are going to have x is equal to a cos omega t. Then let's differentiate this one. Therefore, when you differentiate this one, which is displacement, when you differentiate displacement with respect to t, you are going to have velocity. That is, the x, the t will give you what? Velocity. Therefore, this one will become v is equal to, then when you differentiate cos, it will give you minus sign. Then this one is constant to come back here. So you are going to have minus a omega sine omega t. Then this one, don't forget, differentiation of cos will give us what? Minus sign. Now let's redifferentiate this one so that we get acceleration. Now we have acceleration. Don't forget the v, the t is equal to a. So when you differentiate the velocity with respect to t, you are going to have a is equal to, then when you differentiate sine, it will give you cos without minus. So we are going to have a minus a, then this omega will come back here. So we are going to have omega square again cos omega t. Then let's rearrange it very well. We are going to have acceleration is equal to minus omega square a cos omega t. Then this a cos omega t, which is same thing as a cos theta, is same thing as x. Therefore, acceleration is equal to minus omega square what? A. So this is the formula for acceleration of a simple harmonic motion, where this negative indicate that the velocity, acceleration is in opposite direction to the what? Displacement. You can see because acceleration is directed towards this fixed point, but displacement is directed towards this side. So they are opposite to each other. So if you want to apply the formula, you apply it as like A acceleration is equal to omega square x. So this is formula for acceleration under simple harmonic motion, where this one is omega, which is 2 pi f or 2 pi over t. Then this x is what? Displacement. Now let's go to velocity. Velocity at midpoint or end point or at any point along the motion. Now we are going to use formula for acceleration. So in that case, we have to integrate this acceleration. Don't forget, when you differentiate velocity, you get acceleration. When you integrate acceleration, you get velocity. Therefore, from A is equal to minus omega square x, let's integrate this one back. So when you integrate this one, it will give you integral of v dv is equal to minus omega square integral of x dx. Then when you integrate this one, it will give us v square over 2 is equal to minus omega square. Then this one integrate x with respect to x will give us what? X square over 2. Then when you are integrating, you have to put what? Constant plus c. Now what will now be the value of c? So in that case, you have to look for the value of c. Our value of c, we just assume that at maximum displacement, when this x become a, what will happen to velocity? So at maximum displacement, then our x become a, then our v is equal to 0. Put it here. If x is equal to a, this one becomes 0. The whole of this one become 0. So in that case, we are going to have is 0 is equal to minus omega square. Then this one become a square over 2, then plus c. So in that case, when you bring this one here, so our c, this implies that c is equal to omega square a square over 2. Then we now bring it back to this point. Substitute it here. So our c is equal to this. Then we have this. Therefore, we have v square over 2 is equal to minus omega square s square over 2 plus omega square a square over 2. Let's rearrange. Bring this one here and take this one here. So it will give us, or let's divide through by 2 first and rearrange it. This one will cancel this. So we have v square is equal to, write this one first because it has what? Plus omega square a square omega square s square. Then omega is common. Let's factor it out. Therefore, v square is equal to omega square open bracket a square minus s square. So in that case, we find the square root of both sides. Now give us v is equal to square root of omega square open bracket a square minus s square. Where this s, what? Displacement at any point, then amplitude is displacement at maximum displacement. So in that case, since this one has square root, factor it out. Therefore, v is equal to omega square root of a square minus s square. So this is formula that we need. We need this formula. Take note of it very well. V velocity is equal to omega square root of a square minus s square. Now, what will now happen to velocity at midpoint and maximum displacement? Now, at this midpoint, that is equilibrium point, when x is equal to 0, then you put it here. So therefore, velocity will become omega square root of a square because x is equal to 0. Therefore, v is equal to omega a, and that is what maximum velocity. That shows that this is where we are going to have maximum velocity. Then at this end, don't forget that our x is equal to a. Now, when you substitute, we are going to have v is equal to omega square root of a square minus, then our x become what? A minus a square. Then a minus a will give you 0. So at the end of the day, our v at maximum displacement here will become 0. So when you have to calculate, though we are going to solve question on this in the next video. So at this maximum displacement, take note, don't make mistake. Maximum displacement, not maximum velocity. This guy are going to have maximum velocity, but this point is called point of maximum displacement. Then our x is equal to a. At this equilibrium point, we are going to have maximum velocity. That's why we have v is equal to omega a. Then x is equal to 0. Then, but the formula you need exactly is this form. This formula you need this formula. So now depend on the question. If the question say calculate velocity at the midpoint here, you know that this one becomes 0. But if the question say calculate velocity at end or maximum displacement, in that case, this one become a, everything become 0. Likewise, the acceleration too. Our acceleration, which is a, is equal to omega square x. This one become x at any point, either from here to here. But at this point exactly, x become 0. At this point exactly, x become a. But at any point from here, x will maintain its value. Now, the next thing is the determination of period of simple harmonic motion, and we are going to determine that in two forms using simple pendulum bob and loaded spring. Let's start from that of loaded spring. When you have it like this, with mass. Now, this is our mass m. Then when you apply force, like what I told you in the initial stage, that force vary directly with what? Displacement x. So therefore, when you apply force, the higher the force, that is the mass you are adding, the higher the what? The extension, the displacement. Therefore, F is equal to kx. According to Hooke's law, don't forget that, because we are using what? Elastic material. Therefore, m, this one will change to what? Mass times acceleration is equal to kx. Therefore, a acceleration is equal to kx over l. Then our a, from our formula for acceleration, we have a is equal to omega square x. Then replace it here. So we are going to have omega square x is equal to kx over l. So at the end of the day, this x will cancel this x. So we have omega is equal to omega square is equal to k over l. Then find the square root of both sides. Therefore, omega is equal to square root of k over l. Then don't forget our omega. Our omega, I said it, is either 2 pi f or 2 pi over t. That is 2 pi over t. Then substitute for that here. So we are going to have 2 pi over t is equal to square root of k over l. Then find the reciprocal of both sides. Therefore, t over 2 pi is equal to square root of m over k. Then multiply both sides by 2 pi. We are going to have t, that is period, is equal to 2 pi square root of m over k. So this is the formula for period of simple harmonic motion for that of loaded spring. Now, let's go to the other one, that is when you are using simple pendulum bob with thread. So in that case, you have this, and we have your thread. This is the body. When you display it here, if you come to this place, then the weight of it will be acting downward like this. That is mg. Then this one, the reaction like this. Then you now draw a line parallel to this, like this, so that we have theta here. This is theta. Then this one is our F, the force we apply. Then this is the weight of the object, this bulb. Therefore, when you find the sine theta, we have sine theta is equal to opposite F over hypotenuse, that is mg. So from here it means that F is equal to mg sine theta. And I said it under circular motion that when the theta is very small in radian, we have sine theta is equal to theta. So therefore, we are going to have F is equal to mg theta. Then this force is equal to ma is equal to mg theta. M cancel L. Therefore, our A is equal to g theta. Now, this place, this is x, distance, displacement of the ball from midpoint or equilibrium point. Then this is L. Therefore, we have sine theta again. Sine theta is equal to x over hypotenuse L. Sine theta is equal to x over L. Then our theta, sine theta is the same thing as theta when the angle is very small in radian. Therefore, theta is equal to x over L. Then bring this one, replace this theta with this here. Substitute it here. Therefore, we have A is equal to g x over L. Gx over L. Now, let's continue. Our A is omega square x. Therefore, omega square x is equal to gx over L. Then this cancel this. Therefore, omega square is equal to g over L. Find the square root. Therefore, omega is equal to square root of g over L. Therefore, and pi and omega is equal to 2 pi over t, which is equal to square root of g over L. Then find the reciprocal of both sides. We are going to have t over 2 pi is equal to square root of L over g. Then cross multiply, multiply both sides by 2 pi. Therefore, t is equal to 2 pi square root of L over g. And if you look at this formula, it's very similar to this one. We have 2 pi, we have 2 pi. So under this one, we are varying the length. You'll be changing the what? The length. That is it. But under this one, we are changing the mass. The constant under this one is acceleration due to gravity. Then constant under this spiral spring, loaded spiral spring, is what? K. You can see the similarity in both. So this will be the end of the lesson. And the next video, we are going to have question under this topic.